All right, welcome back to the third part of the trend prediction course. This is the final one. You're almost a trend prediction expert right now. All right. Now in this course, we're going to talk about some prerequisites and some computational resources, but I'm going to kick us off with an explanation of the algorithm under the hood. Now, I'm not going to become too technical. It's just that often users ask me, okay, what are the kinds of techniques that you guys are using under the hood? And so I want to address these questions here. If you're not really interested in this, feel free to skip this slide as we will not use it later in the course. All right, so let's dive in. And this slide is not for the faint of heart. The prediction algorithm that we use, consists of three different steps. The first step is the data pre-processing and seasonality estimation step. The second step is the model building step. And finally, we use that model to create our prediction. All right, what does this data pre-processing and seasonality estimation step entail? Well, whenever you guys open a trend graph, we fetch the trend data, and often that data is not very nice. For example, here you see a spike. Yeah. Now, if you have random spikes in your data and you try to fit a model through that data, then that often doesn't work very well because your model is going to try to take into account this random spike, and you don't want that. So the first thing we do is we're going to try to remove those spikes using a sample filter. Next, we're going to try to detect seasonal and periodic behavior in the data using what we call an autocorrelation function. You can Google this, it's online, and it's a very nice method to find periodic behavior in a time series. Finally then, we're going to look for behavioral changes in the data. We have a nice algorithm for this, and Tobe will explain a lot more on this in the topic called anomaly detection. For now, the only thing you need to know is that our algorithms are able to detect that the data changes behavior right here. Now, if you're going to throw this into a prediction model, again, you're not going to get good results. The problem is that the model is going to try to learn two kinds of behaviors, or it's going to remember the old behavior and stuff like that. So what we do instead is we transform the data. You see that before this jump, the data was fluctuating around 0. Now it's fluctuating around 5. So we're going to shift this first part of the data upward, effectively transforming the original data into this much nicer looking data. This data then is being used in the second step, the model building step. Here, we're not going to try to build just one type of model. We're going to try to build 3 types of models. We call this an ensemble of models. And this is standard terminology. The first thing we do is build or try to fit a fortress model. You will not find this anywhere online as it is proprietary, but it is based on a Holt-Winters model. And there's a lot of information on that to be found online. Next, we also try to fit an FT fortress model. Again, this is proprietary, but it tries to fit the same data with a few less parameters. And finally, we apply an auto-ARIMA fitting. Again, this is something that you will be able to find online. Now, once we have 3 distinct types of models, once we have 3 models for our data, we're going to look at the one which performs best. How do we do that? Well, during the model fitting, we don't use all the data to train the model. In fact, we omit 10% of the trend data and only use 90% to fit the model. Once we then have the model, we try to predict the omitted 10% of the data. And we see how well the predicted values and the omitted original values coincide. Based on this, we're able to decide which of the 3 models was best. Once we have this best model, we still have to check if it is any good. Maybe you have fitted 3 models and they're all equally bad. That can happen. So then we do some further sanity checks to make sure that this model really performs decently. Here, amongst other things, we use what is called the Maze factor. And you can find that online as well. As the final step then, we're going to use the model to create a prediction. That means that on every aggregation level, the real-time level, the 5-minute, the hour, and the daily level, we're going to have models, and each of them will create its own prediction. This gives us 4 predictions that partly overlap in time. Indeed, the 5-minute prediction overlaps with the hourly prediction partly. So using these 4 predictions, we're going to use information from all the different predictions to improve every single prediction slightly. And that, in a nutshell, is how the trend prediction algorithm in Dataminr works. All right, before concluding the chapter on trend prediction, let me just mention a few prerequisites and computational resources. Prerequisites, not much. You only need trend data. So you only need Cassandra or Stath, whatever you prefer. The trend prediction algorithm can be enabled and disabled via System Center, System Settings, Analytics Settings, Analytics Config, Trend Prediction. There you can easily switch it on or off, although I wouldn't see why you would switch it off. The amount of resources it uses is very, very low. It does nothing at all unless you're opening a trend graph. And then the only thing it does is building these models on the data. But these algorithms are so well fine-tuned over the last, say, 8 years. They're so fast that you will not even notice it. It will also not block your system. It can happen that the trend graph, the trend data already appears and that the prediction appears a little bit later. So there's no reason to switch it off, believe me. Okay, that's it. That's trend prediction. If you want to know more about it, if you want to see more examples, feel free to check out any of those. We even have some nice videos. We have information in our docs. So yeah, if you want to know more, check that out. And I'm looking forward to seeing you in our next lesson on proactive cap detection. Bye-bye.